let's analyze a few statements based on some of the theorems that we know. So we've got this diagram up here, and we're going to look at other statements that are given here, and if these statements are true, does that necessarily mean that AB and AC are perpendicular? Let's take a look at where AB and AC actually are. So AB is this line, AC is this line. Really, the only way to say that those are perpendicular is if we can know for sure that we've got a right angle in here. In other words, this all adds up to 90 degrees. Another thing to make note of is that we've got a straight line here, so it can be said that angle 1 plus angle 2 plus angle 3 plus angle 4 have to add up to 180 degrees. That also means that if I could say something like angle 1 and angle 4 together are 90 degrees, then that would leave me with the remaining 90 degrees in here with angle 2 and 3. Okay, so a couple things to keep in mind as we analyze these statements. Okay, so the first one says, let's say that we know for sure angle 1 and angle 2 are congruent. If this angle is congruent to this angle, does that tell us for sure that we've got perpendicular lines here? And we'd have to say in this case, no, it does not. That's not enough information to tell us that this is 90 degrees in here. We've got part of this that is congruent to that, but that doesn't mean I know enough about the rest of what's happening there. Okay, so let's look at the second statement. What if we know for sure that 3 and 4 are complementary? Okay, if 3 and 4 are complementary, they add up to 90 degrees, that means I've got a right angle in here. That tells me that this is also a right angle. So these two, angle 1 and 2, must also add up to 90 at this point. Does that mean that 2 and 3 together are perpendicular lines? Are they a right angle in there? And again, for this one, we'd have to say no. The reason for that, let's say 1 is 40 degrees and 2 is 50 degrees. That would add up to 90. Let's say 4 is 40 degrees and 3 is 50 degrees. That would also add up to 90. So that would make those things right angles and perpendicular lines. But that would mean I'd have a 50-degree angle and a 50-degree angle in here. Altogether, that would be 100 degrees, and that's way too big to say that those are perpendicular lines. All right, next one. Angle 1 and angle 3 are the same. Let's mark that. Angle 1, angle 3. And also angle 2 and angle 4 are the same. We'll mark those in a different color, but that's the same. All right, is that enough for me to say that we've got perpendicular lines in here? That, in other words, that BAC is a right angle. In this case, we would say yes. That is going to be enough. And if you think about it this way, what I said before, angle 1 and 2 and 3 and 4 all add up to 180 degrees. Half of that is shown in red, and half of that is shown in blue. So if I would split that 180 degrees in half, I would have one half that is part red and part blue, what I've got marked there, and the other half that is part red and part blue, which is marked here. This has to be 90 degrees, and this has to be 90 degrees. So therefore, we've got perpendicular lines. And then finally, the last one. What if angle 1 is 40 degrees up here, and angle 4 is 50 degrees? That's kind of similar to what we just saw. Altogether, 1 and 4 add up to 90. That would leave us with the remaining 90 degrees in here, and so we would say that that is a perpendicular lines that are formed. Okay, so a couple different types of analysis. Down below, you've got something similar. We're looking at a bunch of different types of windows. I'll just show these to you, and you can go back and analyze them on your own. A bunch of different lines on the outside of the window, and some are marked. They might be hard to see on your page. Some are marked with 90-degree squares there. We could say that Z and Y are parallel lines, and here's how you would write that. The reason is that both of them are perpendicular to W. So here's Z vertical, here's Y vertical. Those are parallel lines. They're both perpendicular to angle W that's cutting across there. And we could also say that V and W and X, all these horizontal lines, are also parallel because all of them, well, V and W are perpendicular to Y. So here's Y. V and W we know are perpendicular to them. W and X, so here's W, here's X, they're perpendicular to Z. So all of them have to be parallel. We see some of the similar kind of stuff down at the bottom here. F is perpendicular to, or excuse me, is parallel to G because of the lines that they're perpendicular to. N and P have to be parallel. P and Q have to be parallel, and S and T have to be parallel as well. If you're up for a challenge, take a look at this, the open middle challenge problem dealing with perpendicular lines and their equations. Hopefully that's something that you can do.